Dear 11th class students, today we are starting permutations and combinations. Here we are first going to introduce factorial. What is the notation of factorial and what is the meaning of factorial? I'll explain, because we use this factorial notation in coming 2 to 3 chapters. So factorial means the product of first n positive integers is known as factorial n. The product of first n positive integers is known as factorial n and is denoted by n factorial. Understood? So n factorial means product of first n consecutive, this word is so important, product of first n consecutive positive integers. So the product of first n consecutive positive integers is known as factorial n and is denoted by n factorial. It is read as n factorial. So n factorial means 1 into 2 into 3 into 4 into so on into n. That is the meaning of n factorial. Suppose 5 factorial means 1 into 2 into 3 into 4 into 5. 3 factorial means 1 into 2 into 3, etc. Did you understand? So now we are going to discuss about 0 factorial. 0 factorial means the product of the numbers from 1 to 0, which does not make any definite sense. So 0 factorial has no definite sense. If you compare with the definition of factorial n. So 0 factorial has no definite sense, so we take 0 factorial as 1. So hereafter 0 factorial means 1, you have to understand. So please don't think more than required about this. In fact, 0 factorial has no definite sense, so you are taking it as 1. Next, deduction. So as we have discussed, n factorial is n into n minus 1 into n minus 2 into so on to 5 into 4 into 3 into 2 into 1, or 1 into 2 into 3 into so on up to n. Makes no difference because product is commutative. 2 into 3, 3 into 2 gives you same value. So n factorial is this. Suppose you want to deduce, this deduced as n into from n minus 1 up to the consecutive product till 1 gives you n minus 1 factorial. So n factorial can be deduced as n into n minus 1 factorial, and again the same way n factorial can be deduced as n into n minus 1 into, from here if you take the consecutive product up to 1, so it is n minus 2 factorial. So n factorial can be deduced as n into n minus 1 into n minus 2 factorial. Similarly, n into n minus 2 into, okay, n into n minus 1 into n minus 2 into n minus 3 factorial. So like this, okay, in a convenient manner you can reduce n factorial. Did you understand? Once I will explain, see, n factorial means this. So now if you take n and if you start calculating the product from n minus 1 to 1, all these consecutive integers product, okay, if you gather, it is nothing but n minus 1 factorial. So it is n into n minus 1. You extend like this, you get all this. Understood, I think? See, dear students, now we are going to discuss about fundamental principles of counting. So there are two fundamental principles of counting which play a major role throughout this chapter, permutations and combinations. And it's not exaggeration, without this fundamental principle, no problem can be solved, okay, throughout the permutations and combinations. So that much importance is there. So there are two fundamental principles of counting. One is fundamental principle of multiplication and another is fundamental principle of addition. So what is fundamental principle of multiplication means? See, if one action, what it may be the action, okay. So one action is performed in m ways and another independent action is performed in n ways, then both these actions can be performed in succession in m into n ways. Okay, in succession means, okay, after one another action should be performed, but both the actions should be performed one after the other. Okay, so if both these actions performed only, okay, we consider that the given action is completed. Did you understand? So both actions should perform, okay, so that you can complete that given action. Okay, so that given action is compounded with these, okay, sub actions, and all these actions when are completed one after other, that given action is performed. That is the meaning. Okay, so okay, so that the action can be performed in m into n ways. See for example, there are 3 ways from Hyderabad to Vijayawada. Say, and there are 2 ways from Vijayawada to Rajahmundry. Here 3 ways, 2 ways. Okay, then a person should travel from Hyderabad to Rajahmundry via Vijayawada. Okay, this is the program. Okay, so then traveling Hyderabad to Vijayawada is one action, and then okay, traveling Vijayawada to Rajahmundry is another action. Both these actions have been finished, so he travelled from Hyderabad to Rajahmundry via Vijayawada. So this action is performed in 3 ways and this action is performed in 2 ways. Then both the actions together can be performed 3 into 2 ways, which is 6 ways. This is the central idea of fundamental principle of multiplication. Understood? Now, fundamental principle of addition. Say if an action is performed in m different ways and another action is performed in n different ways, okay, then any one of these actions is performed in m plus 1 ways. So m plus n ways. So this is the fundamental principle for addition. So here the main difference between the fundamental principle of multiplication and fundamental principle of addition is, in the first principle, okay, all the actions should be performed one after the other, okay, and then that action, the complete action is performed. Here these actions are not necessary to be performed one after the other. if any one is happened among these actions, if any one is happened, that action, okay, is considered to be happen. So this is lot of difference. You please try to understand. In the first case, all the actions in succession should be performed. Here, not necessary. Only any action is performed, our action is finished. See, for example, if I give an example, see, there are 3 girls and 2 boys in a classroom. Okay, so a teacher should send either a boy or a girl to, okay, address a meeting. So the teacher should send either a girl or a boy to address the meeting. So if girl has addressed the meeting, then okay, that action is finished. Or if the boy addressed the meeting, then okay, the action is performed. The action is finished. So if this happens or this happens, okay, our action is performed. So either girl or a boy should address a meeting. A teacher should send either a girl or a boy to address the meeting. Okay, then how many ways it can be done? 3 plus 2, which is equal to 5 ways. So this is the main difference between these 2 fundamental principles, and most of the students will fail to catch the sensitive difference between these 2 actions, and then okay, so that they will not be understanding the problems, though a teacher solved n number of problems also, okay, he will be ending up with chaos, and he will be having a doubt always in the mind that why teacher sometimes using m into n, and why teacher sometimes using m plus n, where to use m into n, where to use m plus n, okay, that okay, for this question, so answer is a myth for the student. So please, dear students, please understand this carefully. A very simple way, okay, you can easily understand. So fundamental principle of multiplication, whenever you are using, all actions should be performed consecutively. Fundamental principle of addition, when you are using, only one of the actions should be performed, then that action is considered to be performed. Understood? Now, dear students, we are going to discuss about permutation. Permutation means arrangement, arranging the things in an order. Okay, so permutation means arrangement, arranging the things in an order. It's a very simple definition of permutation. Suppose, see, there are 3 things for you which are given A, B, C. So these 3 things you are using, say, suppose, not necessary to use all the things. Okay, so you are using in this present situation, you are using all the 3 things. So if you are using all the 3 things and you are making the different possible arrangements, okay, practically, if you are seeing in how many possible ways that you can arrange, if you see practically, this is one, this is another one. See, please see, observe. Okay, this is another one. Okay, ABC, BAC, CBA, BCA, ACB. Okay, BAC over, okay, CBA, BCA, ACB. Okay, CBA, BCA. See this ABC, BAC, CBA, BCA, ACB, CAB. So 1, 2, 3, 4, 5, 6 permutations you got. Okay, if the set of given things is ABC, and if you are using all the given things from this set, and if you are making the all possible arrangements, and you can see now these 6 are the only possible permutations that can be made by using the 3 things from this set. These are called as each of these arrangement is known as a permutation, and such permutations are in number 6 here. Each of the above arrangement is known as a permutation, and such the number of such permutations is 6. Did you understand? This is the concept of permutation, arranging the things using some of the given things or all the given things. You can make arrangements, and here in various situations we need to find the number of such permutations. In this problem we took the permutations practically and we have counted the number of permutations, but it is not possible in every cases. Practically writing the arrangements and then counting the number of arrangements is practically is not possible in all situations. Then we have to go for a principle, we have to go for a theorem which gives you the number of permutations, using which you can calculate the number of permutations without actually writing the permutations. Understood? Now I am going to introduce you a notation, and then the meaning of the notation, and then it's a rule, principle, it's a formula. What is the formula for that notation? So first notation is NPR. The notation is NPR. The meaning is N stands for the number of things that present in the given set, the number of different things that present in the given set, that stands for N. P for permutation. R for the number of things that you are using from that given set to make a permutation. So please understand this point. N stands for number of things, the number of different things available in the set. P stands for permutation, and R stands for number of things that you are using from that set to make an arrangement. And overall NPR means the number of such permutations. The total number of such permutations means from the given set of n dissimilar things, if you are using R things and you are making the arrangements of R things, then how many such permutations, what is the number of such permutations you get? For that the notation is NPR. This is a notation meaning. Now the formula is NPR is equal n factorial by n minus r factorial into r factorial, or you can take as n into n minus 1 into n minus 2 into so on n minus r plus 1. So this is the notation. The meaning already I explained. That formula is NPR is equal n into n minus 1 into n minus 2 into so on n minus r plus 1. Now we are going for a deduction. Now we are going for a deduction. NPR is equal n factorial by n minus r factorial. So we are going to go for this deduction. How will go, you see. So we know that NPR is equal, by definition we know that NPR is equal n into n minus 1 into n minus 2 into so on n minus r plus 1. Now you extend this continued product till 1. You extend this continued product till 1 so that you have to divide even with the same quantity. Now what will happen, right? This n into n minus 1 so on up to 1, the continued product of the first n positive integers, it is okay, it is n factorial. Now see here, actually till here it is existing, so you have made the continued product up to 1. So additional multiplication has begun from here. Okay, the same thing has to be divided. So the same thing is divided so that it gets balanced. So the numerator gives you n factorial and the denominator gives you n minus r factorial, because from n minus r you have gone up to 1. So the deduction for NPR is n factorial by n minus r factorial. Understood? Now suppose you want 6p2 for example, then if you use that original formula, just 6 into 5, okay, you can use any one or your wish according to situation, okay, that at that time, okay, which is instantly, okay, in your mind, flashed in your mind, that can be used, but any one you have to use. So 6p2 means 6 into 5, 7p3 means 7 into 6 into 5, 10p2 means 10p4 means 10 into 9 into 8 into 7, like this, etc., etc., etc. So you have to begin with say 6 here, which is n value, and 2 factors, okay, continued product you have to take when here there is 2. So when here there is 3 continued, okay, 3 factors you have to take beginning with 7. When here there is 4, okay, the continued factors up to 4 numbers you have to take beginning from 10, here because it is 10. Please do understand, it is very simple. So 9p3 means you have to begin with 9 and that continued product you have to take up to 3 factors. So 9 into 8 into 7, etc. I think now you understood how to find this NPR value, okay? Dear students, now we are going to do some problems. First one is 2 into 5p3 is equal to np4. So what is n? This is a question. So first and foremost, 2 into 5p3 means, you know, 5 into 4 into 3, right? And np4 means n into n minus 1 into n minus 2 into n minus 3. Following this 3 2s are 6. So 6 into, are you following? 3 2s are 6. So 6 into 5 into 4. Okay? Or you can say like 1 minute. So As I said, if you take 6 into 5 into 4, here you are getting only 3 factors, but here there are 4 factors, so should make somewhat 4 factors, so consecutive 4 factors. Though 6 into 5 into 4 consecutive only, but 3 factors only you are getting, but here there are 4 factors. So here you should see that it is a product of 4 consecutive factors. So you can write it as 5 into 4 into 3 into 2 is equal to n into n minus 1 into n minus 2 into n minus 3, which is nothing but 5 into 5 minus 1 into, okay, 5 minus 2 into 5 minus 3, right? 5 into 5 minus 1 into 5 minus 2 into 5 minus 3, which is equal to n into n minus 1 into n minus 2 into n minus 3. So if you just compare, it is very clear that n is equal to 5. So this is the answer. Understood? Dear students, our next question is 5pr is equal to 2 into 6pr minus 1, then find r. Okay, now solution. So 5pr, if you go for npr formula, so 5pr is 5 factorial by 5 minus r factorial, because npr is n factorial by n minus r factorial. This formula we have. It's equal to 2 into 6pr minus 1 means 6 factorial by 6 minus r minus 1 factorial. So this is equal to 5 factorial by 5 minus r factorial is equal to 2 into 6 factorial can be deduced as 6 into 5 factorial. This is 6 minus r minus into minus plus 1. 6 plus 1 minus r means 7 minus r factorial. Then this 5 factorial get cancelled. So this is 1 by 5 minus r factorial is equal to 2 6 are 12, you can take, by 7 minus r factorial can be written as 7 minus r into 7 minus r minus 1, okay, 7 minus r minus 1, which is 6 minus r, next 7 minus r minus 2, okay, 7 minus r minus 2, which is 5 minus r factorial. So 7 minus r factorial can be reduced as 7 minus r into 6 minus r into 5 minus r factorial. Now what happens? This 5 minus r factorial, 5 minus r factorial get cancelled. Then you are left with you go for cross multiplication, 7 minus r into 6 minus r is equal to 12. Okay? So this implies, suppose if you put r is equal to 3, 7 minus 3 into 6 minus 3, which gives you 4 into 3, which gives you 12 only. So 7 minus r into 6 minus r is equal to 12 is satisfied by r is equal to 3. Therefore, r value 3. Understood? Our next question is, if 10pr is equal to 5040, then find r. So take 5040 first. So which is 10 into 504. 10 into 504 is this only, no? Now go for prime factorization of 504. Okay. Suppose you go for 9 into 8 into 7, for example. I am saying only for example. So 7 9s are 63. 63 into 8. 8 3s are 24. 8 6 are 40. 8 50. See, exactly it is matching. So 504 can be written as 9 into 8 into 7. So 5040 is equal 10 into 9 into 8 into 7 is nothing but 10p4. Therefore 10pr is equal 10p4. Therefore r is equal to 4. Understood? Our next question is, if n minus 1 p3 is to np4 equal to 1 is to 9, then find n. This is the question. So now take n minus 1 p3 means n minus 1 into n minus 2 into okay n minus 3. Okay, just you have to reduce 3 factors, 1 2 3. Is 2 means by. np4 means n into n minus 1 into minus 2 into n minus 3. It's equal to 1 is to 9 means 1 by 9. So this n minus 1, n minus 2, n minus 3, n minus 1, n minus 2, n minus 3 get cancelled. 1 by 9 is equal to 1 by n. Therefore n is equal to 9. Understood? How many different signals can be made by 5 flags from 8 flags of different colors? So from 8 flags of different colors, how many different signals can be made, okay, using 5 flags? So here it is very simple. The n value is 8 different flags. You are using 5 flags from them, r is equal to 5. And the number of signals is NPR, okay, it's nothing but 8p5. 8p5 means 8 into 7 into 6 into 5 into 4. See, you have reduced exactly 5 factors starting from 8. 1, 2, 3, 4, 5. This is 8p5 value. So if you multiply, say 5 4s are 20. 26 are 120 and 8 into 7 56. 56 into 120. Okay, if you multiply this, whatever the number you get, that is a number of permutations. Understood? So this product is 6720. So therefore number of different signals is equal 6720. That is the answer. Okay, this problem is finished. Dear students, our next question is, how many different signals can be made by using any number of flags from 5 flags of different color? See, that previous problem and present problem, okay, though relating to signals and flags, you may be, okay, seeing some similarity in the question, but the meaning wise, okay, there is a lot of difference. Please understand. There we are using exactly 5 flags from 8. Here from 5 flags you can use any number of flags, but to make a signal, at least one flag has to be chosen. Without flag, choosing flag, you cannot form a signal. Okay, so here how many different signals can be made by using any number of flags means, okay, you can use any number of flags from 5, means starting from 1 you can use any number to, okay, to make the signal. Okay, so the required number of permutations is equal to, okay, the number of signals made with 1 flag plus number of signals made with 2 flags Any number of flags, he said, no. So in the previous problem, exactly 5 flags must be used from 8. So we have used 8p5. But in that case, this case is something different. He is saying any number of flags can be used to make the signal. So one flag can be used, 2 flags. So 1 or 2 or 3 or 4 or 5. So here fundamental principle of addition will come into the picture. So 5p1 plus 5p2 plus 5p3 plus 5p4 plus 5p5. So 5p1 means 5 factorial by 5 minus 1 factorial. 5p2 means 5 factorial by 5 minus 2 factorial. 5 factorial by 5 minus 3 factorial. 5 factorial by 5 minus 4 factorial. 5 factorial by 5 minus 5 factorial. This is nothing but 4 factorial. 5 factorial by 4 factorial means 5 into 4 factorial by 4 factorial. So it is 5. So this is 5 factorial by 3 factorial means 5 into 4 into 3 factorial. Are you following? So 5 factorial means 5 into 4 into 3 factorial. Are you following? See here, this is 5 factorial means, see, I will explain clearly. This is 5 factorial by 4 factorial, or else you take one step. 5 factorial by 4 factorial. One step let us take to have clear understanding. This is 5 factorial by 3 factorial. 5 factorial by 2 factorial. 5 factorial by 1 factorial. 5 factorial by 0 factorial. So this is 5 into 4 factorial. So 5 into 4 factorial by 4 factorial. This is 5 into 4 into 3 factorial by 3 factorial. This is 5 into 4 into 3 into 2 factorial by 2 factorial. This is 5 factorial. This is 5 factorial. Are you following? Are you following? So now this 4 factorial get cancelled, 3 factorial get cancelled, 2 factorial get cancelled. So this is 5 plus 5 4s are 20, 5 4s are 23 is a 60 plus 2 into 5 factorial. 5 factorial means 5 into 4 into 3 into 2 into 1. This is equal to 60 plus 20, 80, 80 plus 5, 85. Plus 2 into 5 was a 20, 23 is a 60, 62 is a 120. So this is 85 plus 2 into 120, 240. So if you add 240 and 85, this is 5, 8 plus 4, 12. So you get 325. So number of such permutations is equal to 325. Understood? So how many 4-digit numbers can be formed using distinct digits? So what are the distinct digits available? Available distinct digits are 0 to 9. So available distinct digits are 0 to 9. So n value is 10. Okay. Now, say 4-digit number you have to form, right? So see, dear students, this units place, this tens, hundreds, thousands place. In thousands place there should not be 0, right? In thousands place there should not be 0. In order that to be a 4-digit number, 1000 place should not be 0. So ignore 0. If you ignore 0 to fill this position, okay, then there are 9 numbers available if you ignore 0. So okay, any of those 9 digits can be filled here, right? right. So this can be filled in 9 ways. Now you have to fill this. Okay, overall 10 digits are there. So from that, here you have used 1 digit. Then how many are left over? Are you following? See here. Once I'll explain. See here. 0 should not be in the thousands place. Units, tens, hundreds, thousands. In this thousands place, there should not be 0. So if you ignore 0, so how many are there? 9 digits are there. So okay, any of those 9 digits can be filled here. So number of ways to fill up this position is 9. Now there are 10 digits, and among them you have used 1 digit here. So how many are left over? 9 digits are left over now. Okay, are you following? So this second position can be filled with any of those 9 digits, and this third position can be filled with any of the 8 digits available, the 7 digits available. So here n is 10. So as 0 cannot be in thousands place, number of permutations is equal nine into 8 into 7, right? So 8 9s are 72 into 7 9s are 63. So you have to multiply this. So if you multiply this and this, you get 4536. So 4536, okay, 4 digit numbers can be formed using the distinct digits available. Here one point is very clear that repetitions are not allowed here, means you are not entertaining repetitions, means the used number cannot be used in the same permutation. Like you are not taking this kind of numbers like 2236 or 2336. This kind of numbers have been not included in this total number, because here the digits are repeated. So you are not allowing the repetitions. So here this 4536, okay, represent the number of all 4 digit numbers using the available 10 distinct digits, in which no digit is repeated. Understood? I am doing the same problem in different model. Available, okay, digits are these, and the number of digits 10. Okay, now number of 4 digit arrangements, I am not saying numbers, just I am saying 4 digit arrangements. Number of 4 digit arrangements you get equal to 10p4. So number of 4 digit arrangements, I am saying 4 digit numbers, I am not saying, please do understand. So number of 4 digit arrangements you get 10p4. So are you following? This 10p4 arrangements, there are even, okay, those arrangements are counted, okay, which have begun with 0. Okay, as far as arrangement is concerned, so no significance of the value of the digit, but as far as number is concerned, 0 should not be in the beginning position. So now I am counting how many permutations are holding 0 in the first position. So when 0 is there here, okay, now how many things can be used here? Here, in how many ways this position can be filled? This can be filled in 9 ways. Okay, do you agree? This can be filled in 8 ways. This can be filled in 7 ways. 9 ways, 8 ways, 7 ways. So in which, okay, 9p3 arrangements have 0 in the thousands place. So therefore now we have to write, therefore number of 4-digit numbers is equal to 10p4 minus 9p3. We have to subtract these all arrangements now. So which gives, if you simplify, you get the same answer, 4536. So this is another method to solve the same question.